All right, so we are putting it all together now that we know everything about surface area and volume of all different types of solids. How can we use it? Well, so let's start with number 1 and look at some examples. So this says an ice tray can make 14 ice cubes. If the length of each cube is 2 inches, what is the total volume of the ice tray? So it tells us what it wants, the volume. And it says that these are cubes. Now a cube is a special type of prism where the length, the width, and the height are all the same. So all of the edges of the cube are the same. So the volume is each of the sides times each other. So length times width times height, or side times side, since they're all the same. And so a shortcut is just thinking of it as side cubed. So to find the volume of one cube, it would be the length times the width times the height. Well, each of those are 2. So 2 times 2 times 2 is 2 cubed, or 8. So that's the volume of one of these ice cubes. But there are 14 ice cubes in this tray, this problem said. So all we have to do is 8 times 14, and that gives us a volume of 112 cubic inches of ice in this tray. Okay, next one, it says you need to wrap a gift for your cousin's birthday. Your box has these dimensions. How much paper do you need if you don't want any of the paper overlapping? So this is cluing, all these key phrases are cluing us into that we're solving for the surface area of this present, and it's a prism. So it's the surface area of a prism, which we know is 2b plus ph. So b and p are coming from the base of this present, which is this rectangle on the side. So we focus in on that. The dimensions of that base are 4 and 11. So the area is 4 times 11, or 44. The perimeter, adding them all up, gets us 13. Now the dimension left over, the distance between the two rectangular bases, is 15. So the height of our prism is 15. Once you identify all those and you just plug it into your formula, 2 times 44 plus 30 times 15. We can combine this all together and it gets us 538 square inches of wrapping paper in order to wrap that. All right, and the last one, they want us to order the volume of these ice cream treats from greatest to least. And show the math that supports your answer. So first of all, let's identify what we have. We have a cone-shaped ice cream treat, we have a cylinder, and we have a prism. Volume for each of these, volume of our cone is 1/3 area of the base times the height. Volume of the cylinder is area of the base times the height. And then the volume of the prism, same thing, area of the base times the height. So it would probably be smart of us to find B and H for each of these. So let's just do a little investigating. This base of this cone is a circle, so it's pi r squared. Since the diameter is 4, the radius is 2, so B is 4 pi. The height of this cone, this dimension here, is 6. Same thing for the cylinder. The base is a circle, so the formula is pi r squared. Same thing, radius is 2, so the area of the base is 4 pi. The height of this ice cream treat is 6 as well. And then the prism, area of the base here, the base looks like it's a 4 by 4 square. So 4 times 4, the area of the base is 16, but the height is still the same at 6. So now that we know B and H for each of those, we can plug them in. For the cone, 1/3 4 pi times 6 comes out to be 8 pi. For the cylinder, the area of the base is 4 pi, the height is 6, so we get 24 pi. And then the prism, the area of the base is 16, the height is 6, so we get 96. So we found the volume for all 3 of these ice cream treats, and so now we need to compare. Now when we look at these 3 volumes, 8 pi, 24 pi, and 96, we can compare the 8 pi and the 24 pi because they're both in terms of pi, but the 96 is not. So what we need to do is actually multiply out. You can do 8 times pi or 8 times 3.14 to get an approximation. Same thing with the 24 pi. And we get that this 8 pi is about 25.12 cubic inches. 24 pi is about 75.36 cubic inches, and then 96 is 96 cubic inches. So now that we have them all in the same form, now we can compare. They wanted us to list it from greatest to least volume. So the greatest volume is 96, which was that ice cream sandwich. So the ice cream sandwich has the greatest volume. And remember, that was the prism. And then it looks like the cylinder, which was that push pop, had the next largest. So that was the cylinder. And then the ice cream treat with the smallest volume, the least amount of ice cream to eat, was the ice cream cone. And that is just a cone shape like it says it's in its name. So here is our answer. We were able to list the volumes from greatest to least. All right, I hope that makes sense, and congratulations, you guys just finished your surface area and volume chapter. Now it's time to study for the test.